To perform the commissioning with the laptop, you just need an Ethernet cable if you want a wired connection, or Wi-Fi drive link module for a wireless connection, and then the WEG DriveLabs configuration software. Wi-Fi drive link module is an accessory that can be purchased separately from the drive. Let's do the unboxing. Into the box we find the module, a small box to carry the module, and the instruction sheet to recover the manual of the Wi-Fi drive link module and of the app WEG Lift Touch. WEG DriveLabs is the name of the configuration software. It is dedicated to Windows, and it can be downloaded directly from Download Center on WEG website. To download the WEG DriveLabs configuration software, it is necessary to reach ADL500 web page, click on Download Center, go to the section Software and Firmware, and click on WEG DriveLabs. Now we are ready to power on our system and connect to the drive. Once the drive is on, we can start the procedure to connect our laptop to the drive. We will start with a wired connection and then show how to get a wireless connection to cover all the options. If we want to use the Ethernet cable to connect to the drive, let's use the dedicated port on the drive and plug the cable. And then to the laptop. Let's open WEG DriveLabs configuration software. In this page, let's scan all the drives that are available on the net. The drive has an IP address set to static by default, which is 169.254.10.10, which is the default. Let's click on Start Scan and wait until we find it. The configuration software found this model of drive, which is the one we are using, so we can add it to our project. Next page will show green button and green LED to identify that the connection is successful. If we want to use wireless communication, let's use the Wi-Fi module. Before starting, we must check the last 4 numbers of the serial number that will identify the Wi-Fi network. The number in this case is 5001. And then we can plug it on the drive. As soon as we plug it, the light will become green, which means that the module has created the Wi-Fi network. Now let's open the Wi-Fi networks on the laptop and check if we find our module network. Here it is. Let's select it and connect. We must insert the password of the network, which is WEG_admin. Those are the defaults of the network name and of the password. Of course, everything can be customized into the drive. The light on the module becomes blue. Now we can open WEG DriveLabs and connect to the Wi-Fi network. To find the drive, we must insert the name of the IP address of the module, which is 192.168.4.1, and start the scan. Immediately, our configuration software finds the drive, so we can add it to our project. As you can see, the connection is successful, as indicated by this green button and here by this LED. Once we are connected, in this page we can see all the main information about the software configuration of the drive. Now we can start the commissioning with the setup wizard. Setup wizard is a step-by-step procedure useful to prepare the drive for the commissioning. The first step is load application, which means that it is possible to configure your drive with the EFC application, which is the elevator flow control in multi-speed, or with DS417 communication. The default of the drive is EFC, so let's leave none. Then we have the language selection. It is possible here to select the language of the drive. Since the tutorial is in English, let's select English. That is also the default language of the drive. Next step is parameter file load, which means that it is possible to upload a parameter file which is already available on our laptop in order to speed up the commissioning, just making a copy and paste of parameters from another drive. In this case, we will start the commissioning from 0, so let's jump to the next step. Encoder mode. The default is none, which means open loop. In our case, we have a gearless synchronous motor with a Syncos encoder. So let's select Sinus Syncos and jump to the next step. Finally, here we find the database of motors from which we can select one motor in order to speed up the commissioning with the insertion of the data of the nameplate of the motor. The list includes all the most common motors into the market. In our case, our motor is not in the database, so let's jump this and go to the next step. Here we have a summary of all the configuration we have done, and we can proceed with the download. In the case that we have changed the application software, the drive will restart. In this case, we haven't changed anything on the default of the drive, so we can make the download without any restart of the drive. The message that this operation has been successful is here, so we can jump to the startup wizard. Let's move to the startup wizard. We come back to the wizard selection and select startup wizard. This wizard is a guided step-by-step procedure designed for the quick setup of the drive, assisting in the configuration of the main parameters. It includes a series of questions related to the various steps for entering and calculating the necessary parameter to ensure proper operation of the drive and lift application. The first step is the selection of the control type. The selection list includes by default ASI SSC, which means standard VF control. In our case, we must select SIN FOC, which is the synchronous field-oriented control in closed loop. Each setting is configured with its own default values to streamline the drive configuration process. To ensure all parameters are automatically adjusted to the new setting, the drive requires a load default command. This pop-up notification is designed to inform the user of the actions being taken. So we can click yes on this pop-up. Next step is the selection of the communication mode. The choice is between parallel I/O, which is the default, and can open. In our test bench, we have parallel I/O configuration, so let's select this option. The next action is the encoder mode selection. Since we have already selected Syncos encoder into the setup wizard, it is already proposed by the wizard. So let's jump to the next step, which is the configuration of the encoder. For this, let's take a look on the nameplate of the encoder where we found all the data necessary. The first information we have to insert is the encoder supply. 5.2 is the right voltage. Encoder pulses is 2048, which is also the default. And then we have the encoder signal check. Encoder signal check is related to channels to be used between A, B, or A, B, and Z. For this setup, we can leave the default. And let's jump to the next step. We proceed with motor settings. For this reason, since we haven't selected any motor from the database, it is necessary to take a look to the motor nameplate and fill all the data requested. Factory settings depend on the size of the drive we are using. Starting from the rated voltage, let's set 380. Rated current is 22.4 amps. Rated speed is 255 RPM. The number of ports is 11. It is possible to recover this calculation from a simple formula if this info is not displayed on the nameplate. And finally, the torque constant, which is in our case 13.79. This comes from a simple calculation, which is the ratio between the torque generated by the motor and the rated current requested to supply it. All data that are on the nameplate. Let's now jump to the next step. Mechanical data. Mechanical data are already set by default based on the size and version of the drive. Anyway, if we have specific information about the plant, they will be useful in order to better calculate the inertia of the system and improve control, performance, and comfort. We aren't on a real plant, so we will take the default parameters, but let's scroll the data listed. First setting is travel unit selection, which is a unit of measure for speed reference, which can be cabin speed in meter per second, motor shaft speed in RPM, or output frequency in hertz. We leave meter per second. Second selection is the selection of auto recalculation mode. For the first 3 multi-speeds, every time the car speed is changed by changing the mechanical data of the system. If the parameter is set to manual, the first 3 multi-speeds will be entered manually. If the parameter is set to auto, the first 3 speeds are recalculated with respectively 10%, 100%, and 45% of the new car speed. Let's leave manual. After that, we have cabin speed, that is the maximum operating speed of the system. Next is gearbox ratio, that is the reduction ratio between motor and pulley. Being a gearless system, let's leave 1. Rope ratio, that is the reduction ratio to the rope rotation in the shaft between the various pulleys. Pulley diameter, car weight, the weight of the counterweight, load weight, and rope weight. Next step is setting multi-speeds values. Let's leave multi-speed 0 at 0.07, multi-speed 1, which is high speed, at 0.72, multi-speed 2 at 0.32, which is the inspection speed. The next step is the enabling of the EBC. In our setup, we have the EBC500, so we will put on the EBC enable, and then move to the configuration of EBC parameters. Brake holding voltage is 104 volts, while brake holding power is 77 watts, as indicated into the nameplate of the brakes. Speaking about brake power mode, here we have 3 selections: full voltage, boost half voltage, and boost hold voltage. Brake power boost, to define the time for which the output voltage is held, equal to the value of rectified input voltage, and then CAN termination resistor, on or off. In our case, we don't have this termination, so we will leave it on off. At this stage, we are ready to carry out the auto-tune of the motor, which means the real measurement of motor parameters and the automatic phasing of the absolute encoder. Let's click on auto-tune still to start the procedure. The display asks to enable the drive, so let's do it from our control box. Once the drive is enabled, the auto-tune procedure starts. This may take a few seconds, depending on the type of motor being used. We can see the progress on the display with the percentage. Once the procedure is completed, the configuration software asks to open the enable input. Before exit the startup wizard, this pop-up asks us if we want to save parameters into target. We recommend to do it in order to avoid losing all the data we have inserted up to now. Typically, at the end of the startup wizard, when we are on a real elevator, we perform some trips up and down with different loads in order to understand if the comfort, the arrival to the floor, the performances and the safety are in line with the expectation. In this case, we have a test bench, so we don't have any load, and we will just simulate a lift sequence. Lift sequence starts with run command, which is start forward, as well as high speed command. Then we close the safety chain, and the motor starts moving at high speed with the same settings we have done during the startup wizard. Let's imagine that we are on a real elevator, so the cabin is moving now and reaching the floor. So when the cabin reaches the floor, the command changes from high speed to low speed. And then when the cabin is arrived, we remove run command and the brakes close. We have reached the end of this tutorial about the commissioning of ADL550 variable frequency drive for elevator application. We have gone through all the most important steps related to the wiring and to the parameter configuration for a multi-speed setting. Of course, all the information, the complete informations are available on the manuals of the product that are on WEG website. We hope that you found interesting and useful this tutorial, so let's keep in touch to the next one.